The end goal is to build something like this. As you can see, it's all soldered point to point with wire, so it's nothing too complicated. I think anyone can handle this just fine. Here's the first test unit I built. I have another prototype somewhere here. The very first one actually. This is what it looks like. The final version I made looks like this. I've been testing it for a while and have used it in a recording, so pretty much every demo I've recorded since January has used this REAMPING box. Here I've got a second enclosure ready to go, this time green. I just wanted to test different colors. So, what will you need? Some sort of metal box. You can use whatever you like, but it's best if it's metal, so you can connect the ground to it and it will act as a shielding against interference. This is just a standard box like I use for my pedals. As you can see, I've already drilled it. Depending on what other components you get, you'll need to measure and drill accordingly. We'll definitely need a switch here that will serve as a ground lift. It will disconnect the ground from the computer interface from the rest of the signal ground. I use a combo jack like this one. It takes both TRS and XLR connectors. Depending on your interface, you might need one or the other. So a combo jack is a good choice. That way, if you will switch from XLR to TRS down the road, you're covered. I got mine from AliExpress just for a few Polish zloty. What's important is to check the pin connections, because there are separate connections for TRS and XLR. You'll need to bridge those to make sure the signal flows properly no matter which cable you plug in. We'll get to that. So okay, you need a combo XLR TRS jack, a switch, on or on-off works fine, it just needs to break the ground connection. The center pin is a common, and depending on the toggle position it connects to one or the other outside pins. Use whatever you have on hand, the only point is to connect or break the ground. You will also need a metal output jack, this helps ensure that enclosure connects to ground properly. Here you can see I masked it off before painting, so the enclosure connects with the ground going to the amp. Then you need two knobs. I like using big ones for easier control. Two potentiometers, one for input level. I use an 10K logarithmic. In Poland there's some labeling quirk where B is sometimes used for logarithmic, but it doesn't really matter. And the second one for impedance. I use 50K. You can experiment with whatever pots you have lying around. Next thing, the transformer. I've tested a few different ones. I even ordered some just to figure out the cheapest working solution. I tried this super cheap one from AliExpress, 10 pieces for like 16 zloty or something, but they are distorting signal too much and actually it will probably work fine in a fast pedal but not in a reamping box. Finally, I decided to go with TY141P. If you will search for it online, you will find it. I think I got mine on Mouser. You can also find the switches, jacks and even enclosures there. And of course you will need some wire. I prefer using solid core wire over stranded. It's easier to bend and shape neatly. You will also need some kind of foam tape or double-sided tape. We'll use it to stick the transformer inside the enclosure. It holds up pretty well, especially once the wiring is in place. If you're building yours differently, maybe consider glue or mounting it close to a jack for stability. Of course, if the box just sits in your home studio, it probably won't be a problem. But if you ever take it to a friend's or session and something gets bumped, it's really better to secure things. Thin wire can bend, short out, so just keep that in mind. And by the way, the combo jack from AliExpress comes with no screws. I bought a bunch of screws just to have some around for cases like this. These are M3, I think. Not sure about thread spec, but I'll zoom in so you can see next to a ruler. So first I will screw everything in. Watch out for jack orientation, it's easier to wire it if the pins are facing the right way. Also, you can consider using a cloth to avoid scratching anything. I also bought some locking washers to stop the nuts from coming loose. Now about these switches, they usually come with some washers. There's a sun washer and a small one with a little tab. That little tab fits into a groove here to keep the washer from rotating. You can drill a tiny hole in your enclosure next to the switch to insert that tab, and that will stop the switch from spinning even if it goes loose. I don't bother with that though, I just put one nut on first and then the sun washer. That actually locks it in place well enough. Alright, tidying everything up. I also printed out a schematic to show you, forgot to show it at the beginning. I mount everything and then go over it. And a small note about potentiometers. Not all, but some have those tabs for locking into the enclosure. Again, you can drill a little hole like 3 mm, but I just cut off the tabs. This one is for input level, so I'm using 10K. Let's screw it in. Put the washer on, tighten it. Now for the second one, this is 50K. You can try using a higher value to see how it reacts. Especially for output impedance. It's not always audible, but it can affect how some fuzz pedals sound. Remember, the signal here is buffered, and that's how other effects will see it. So this output impedance helps simulate a more realistic guitar pickup load. Also a cool tip, if you have those knobs with small screws, if you will over tighten the screw, you can squeeze the shaft and then the knob starts to loosen and fall off. So what I do is save those little tabs I cut off from other pots, those locking tabs, and I put them in this small gap in the shaft. That fits perfectly there and locks everything in place, so I can tighten it properly without the knob coming loose later. If you don't have those tabs, you can use something like thick wire instead, or something that will fit the gap. Okay, so from the outside it's looking pretty good. I'll put the knobs on last so they don't get scratched while I'm handling the case. Next up, the transformer. I will glue it in. Pay attention here. The transformer has a primary winding, that's the input side, and a secondary is the output. In this one, there's no real difference between them as far as I know, but I marked it just in case. There's a factory dot marking on the other side too, but I like to double mark to see it from the bottom. We'll only use the outer pins, the middle one is the center tab, we won't need it here. So I'm sticking the transformer down with double-sided foam tape. The foam isn't super strong, but once the wires are soldered, everything holds fine. Bit wobbly now, maybe I should use a better tape, or maybe this one dried out from lying around too long. Alright, schematic time, here's how we're wiring it. This is the output from the computer interface, going into the transformer. On the primary side, pin 1. We have a tip, ring and sleeve on the jack. Sleeve is always ground, and it goes to a switch that disconnects the ground. You can see it here. The ground wire goes to the center pin on the switch. When the switch is down, the ground is disconnected. When you flip it up, it reconnects. So now ground in your amp and in your computer are connected. This is connected to the jack and secondary winding of the transformer. The transformer pins are numbered from 1 to 6. The ring, middle connection of the TRS stereo jack, goes to pin 3. The tip, so this part at the end of the jack, goes to pin 1. On the output side, pin 6 goes to the pin 3 on the level potentiometer, and a quick reminder that potentiometer legs are numbered from the top view, so from the view of the shaft. So on the left we have a pin number 1, on the middle pin number 2, and on the right side we have a pin number 3. So the transformer output goes to the pin number 3, the right leg of the potentiometer, the middle leg, pin 2, goes to the middle leg of the next potentiometer, impedance control, and pin 1 goes to the ground, the same ground shared by the jack, the enclosure and the transformer's secondary side. This way, when the level pot is at minimum, the signal is fully sent to ground, so we have a total silence. From pin number 1 of the impedance pot, we go to the signal pin of the unbalanced output jack. That's the output to your amp or FX chain. And our balanced signal is converted to unbalanced. So rather than spending a few hundreds on a reamping box, you can make yourself and use the leftover money for something fun and useful. For example, my pedals. You can go ahead and take a screenshot, I will zoom in a bit so you can capture the schematic if you want to print it out. On the schematic sheet you will also find a full parts list. All the components can be bought from Mouser, like I said, but for sure you can also check the local electronic stores. If you have some spare parts at home, feel free to experiment. You can always run some noise through the device to see how it behaves and how it reacts to the signal, so you can be sure it's not adding or cutting any frequencies. Also, you must know it's totally normal to have a bit high roll-off if you increase the impedance, if you turn the impedance pot clockwise, and also if you will pick the higher impedance potentiometer value. Also, in my opinion, it's good to roll off some highs and lows from the signal, especially if you're going to run your pre-recorded signal through the high gain setup. But of course it all depends on the context and overall preferences, and of course genre of music and a lot of factors. Don't be afraid to experiment, to cut something, to boost something, just see what happens. It's always a good experience to know what happens if you change that or this. So yeah, it's time for soldering right now. Always remember that you don't want to inhale the fumes from the soldering, so if you don't have any fumes extractor, please do it on an open space with open window or even outside. So now we just need to connect everything like I did in the original version. Let's start by making the bridges for the TRS and XLR combo jack. You'll have to figure out the pinout of your jack yourself, because unfortunately Mr. Chinese manufacturer didn't include a datasheet with mine. I had to use a multimeter to check everything. You can do this easily using the continuity tester mode, the beeping diode thing. If you're using a regular XLR or stereo TRS jack, it's much easier to just follow the schematic. I'm gonna start with wiring it up here. Let me grab a small pilers. These will come in handy. I like using them for all kinds of connections. Okay, stripping the insulation now. Here's the schematic again for reference. Let's thin the pins a bit with solder. I'm using lead-free solder, but you do whatever you like and have. So this pin connects to that one and then over here. Since they are close, I'll just bend the wire, dab a little solder and it should be fine. No need to overthink it. I'm pre-thinning the wire to save time, soldering here and here. There we go, nice connection. Now I will run the wire to the transformer. You can angle it upward a bit for a better access. Of course, if you want, you can create your own PCB for this project, but actually this method works enough for me. It's quick and simple and there aren't many components anyway. Next pins are here, just shaping the wire so it fits nicely. Thin the pins again and make it easier. Done! Check carefully for shorts. If anything is too close, bend it away a bit. Always make sure you use enough solder so everything stays in place. You can pre-tin first and then heat everything up to connect it neatly. So the primary side of the transformer is now connected to the jack. Let's move the ground wire out of the way for now and connect the potentiometer next. Here's wire number 1 going to ground. I had already bent these pins a bit earlier to avoid overlap. If you're not using those plastic shields on the pots, be careful because they can create shorts. I will add a bit more solder here. Now this pin needs to connect over to this one, but first we'll bridge the center pins on these pots. As you see, I'm removing insulation from my wires because it looks more vintage, like vintage point to point, but of course you can leave the insulation. But if you're removing insulation, be sure that distances are enough to make no shorts. If the wire keeps slipping, you can make a small hook at the end to hold it in place better. And remember, you can trim the wire after soldering, so you don't have to cut it now. I know I've definitely got more practice than some people watching this. I solder at high temps. I set it to 390 Celsius for lead-free solder. What matters the most is placing the tip properly so the head spreads evenly and quickly melts the solder. Alright, so now we're connecting the ground switch. If you're having trouble getting solder to melt on this pin, turn up the temperature. That's because the entire ground is connected to the frame and enclosure, so it sucks up the heat fast. So we connect it like this. You can cut it or make a small hook and slide it in. Don't solder it yet, we'll take care of another connection too. You can connect it there or here, it's all just ground anyway. I'll make a gentle hook to the side. I'll shape it in a moment, but I will try to solder it together with these other elements. Add some solder, let it cool, and done. I will make a hook here too, both wires should fit. I could have cut it shorter, but whatever, I will fix it. And now we solder it. Bend it upwards, align it, you can bend stuff around, it's good. And now what's left is the signal for the potentiometer. You need to connect it to this pin here. Alright, looks good. When you're touching the wires like this, be careful, they get hot, very hot. So I really recommend using gloves. I have skin issues with my hands, and if I don't wear gloves with handling chemicals or stuff like this, my hands crack and bleed. So I try to use gloves for everything. Experience has shown me it's worth protecting your hands and eyes. With soldering, hot solder can splatter and hurt your eyes. Remember, safety first, take care of yourself, because once you build something cool, you want to actually use it and not poison your household or loved ones. I could have placed those pins a bit closer, they were really near but didn't quite touch, but the solder bridged them. It's enough, it's fine, so I will route this wire up top to keep it tidy, bend it nicely at 90 degrees, I hope it will reach. And basically once we solder this last wire, we're done, just need to close the case. For that kind of modeling I recommend round nose pliers. Hope you can see it well. Let's see if all the connections are there. Yep, looks like it. So now just close the enclosure. Pay attention that nothing sticks out too high to avoid shorting with the case. And check if transformer holds in place. So it's time to put the knobs on. Always set them to the minimum first so you can line them up with the scale properly. Don't over tighten. And there you go, REAMPING box is ready. So yeah, thanks for watching. If you enjoyed this video, please hit the like and subscribe button, share this video to your friends, and see you in the next video. Cheers!